This is a practice exercise, page 293 in the textbook. We're looking at 3 different substances and trying to determine which one has the greatest lattice energy. So it'll help to remember the equation for lattice energy, which is that the energy is equal to constant K times Q, so charge 1 times Q2 over the distance between the two charges. So if we want to maximize the lattice energy, we want to have larger charges and we want to have smaller distances. So the reason we want larger charges is because they're in the numerator, but we want smaller distances because the distance is in the denominator. So if I look at the compounds that I'm dealing with, I've got magnesium and fluorine, and we should know that the charge on magnesium is 2 positive. Charge on fluorine is -1. With calcium, again, we've got a 2 positive, and fluorine, so -1. And then this next one, this is zirconium and oxygen. We know that the charge on oxygen is 2 negative, so if I've got 2 of these, that means the charge on the zirconium must be 4 positive. So I can see that my largest is going to be the ZrO2 because it's got such big charges. Well, what about the other two? What about magnesium fluoride and the calcium fluoride? Can I rank those? Since the charges on these are identical, now we can start thinking about the distance. And the way we tell the distance between the atoms is we think about the atomic radius. So we know that fluorine is going to be exactly the same size because it's the same atom in both of them. So we need to look at the difference in size between magnesium and calcium. So if you look in the periodic table, magnesium is in the 3rd energy level, but calcium is in the 4th energy levels, and because of that, magnesium is going to be smaller than calcium. So if the magnesium atom is smaller, that means that the magnesium ion and the fluorine ion, fluoride, are actually going to be closer together. So since they're closer together, that means we're going to get a higher lattice energy for magnesium fluoride, which leaves calcium fluoride as our smallest. Again, we compared these two based on their distances because the charge was the same, and we knew that this was the largest because it had the larger charges, a +4 and a -2. So whenever you think about greater lattice energies, you have to think about 2 things. You want to maximize the charges, and you want to minimize the distances. And we think about distances in terms of atomic radius.